The next concept is connectivity of a graph. Okay, so a graph is said to be connected graph if there is a path between every pair of vertex. It means if I choose B, from B I have a path to all the other vertices. I can reach to A, I can reach to D, C, I can reach to F like this, I can reach to E. So there is a path. Okay, a graph is said to be connected if there is a path between every pair of vertices. If I say B comma H, is there any path? Yes, there is a path. If I take A comma G, yes, there is a path. Okay, so then we say it's a connected graph. A graph where there is a path from every vertex to all the other vertices. Right? From every vertex to any other vertex, there must be some path to traverse. Then this is called the connectivity of a graph. This is called the connectivity of a graph. It means the graph is connected graph. Okay, when the graph is said to be disconnected, if there is no path. See this example here, after removing of this edge, this became disconnected. Okay, it became disconnected here. So this graph is a disconnected graph. So connectivity of a graph. So if there is no path from a vertex to other vertices, then we say it is disconnected graph. So in this concept, we have two topics. One is in terms of vertices, other is in terms of edges. Let us see that. So connectivity is very simple. If there is a path from every pair of vertices, if there exists a path between every pair of vertices, then we say it is connected graph like this. From B to E, from B to F, from B to G, I have a path. From any vertices, there is a path to all the other vertices. Then we say it is connected. So the next concept is cut vertex. In a connected graph, what is cut vertex? Cut vertex is a single vertex, removal of whose removal makes the graph disconnected. Okay, if there is a connected graph like this, removal of a single vertex, if I remove a single vertex, removal of that vertex, if it makes that graph disconnected, then that vertex is called as cut vertex. That vertex is called as cut vertex if it is disconnecting the graph. Okay, so in this example, if you see in this graph G, if I remove C, if I remove this vertex C, how does the graph becomes? It will become something like this and something like this. See, because I removed this C, this became disconnected graph now. So C is a cut vertex. In the same way, if I remove E, yes, I can still remove E. See, if I remove E, it becomes like this graph. So E is removed. So the graph became disconnected like this into two different disconnected components. Okay, so in this given example, what is the cut vertex? Cut vertex is a set. Cut vertex are the vertices whose removal makes the graph as disconnected. So cut vertices are C and E. C and E are the cut vertices. If you remove C, it breaks the graph. If you remove E, it breaks the graph. It makes the graph disconnected. So given a graph, the task is given a graph, find out which are all the cut vertices in the graph. What is a cut vertex? Removal of that particular vertex from the graph makes the graph disconnected. Maybe you may ask us, what will happen if I remove F? If you remove F, the graph will become like this. This will remain same, then C to E will remain same. See, this is not disconnected. See, by removing F, the graph is still connected in nature. It is not disconnected. Why? From A, I have a path to G, I have a path to H, right? It is disconnected. So that cannot be a cut vertex. Cut vertex is a vertex whose removal makes the graph completely, it breaks the graph into two pieces. Those are called cut vertices. So here C and E can be cut vertices. Either C or E can be cut vertices. So given a graph, find out which all are the cut vertices. So in a connected graph G may have maximum n minus 2 cut vertices. A graph may have maximum n minus 2 cut vertices. If there are n vertices, maximum it can have n minus 2 such vertices. Removal of those can make the graph disconnected. Okay. In the similar lines, there is something called cut set. What is this cut set? Same like cut vertex, cut set means removal of certain edges from the graph. Removal of certain edges from the graph makes the graph disconnected. Okay, so which all edges you have to remove? If you remove certain edges from the graph, it makes the graph as disconnected. Okay, see in this example here, see I am removing, we are trying to remove the vertex BD and BE and CE, this line. If you see the straight line here, if I remove these three edges, it is making the graph like this, say disconnected. It is making the graph disconnected. So cut set is a set, it is a set after deletion of those edges makes the graph disconnected. So for this given graph G, one example, one set could be, one edge set could be B comma D, B comma E, C comma E. This is one cut set. This is one cut set. There can be other cut sets also, right? What are the other cut sets in this given thing? Can I delete these two? Yes, we can delete DF and EG. DF and EG if you delete. No, these two edges if you remove, this graph becomes disconnected. So there can be multiple cut sets. Okay, so you have to find out, given a graph G, which all edges should I remove to make the graph as disconnected? That is the question here, right? So what is cut set? Cut set is nothing but a set of edges, removal of whose, right? If I remove those certain number of edges, that graph becomes disconnected. Whereas cut vertex is removal of certain vertices makes the graph disconnected. So this is about graph connectivity. We have about cut vertex and cut set. So you given a problem like this, find out which are give at least one cut set for this graph G, might be one question. Or for this given graph G, find out the cut vertex, removal of which vertex can make the graph disconnected. Okay, that you have to find it out, right? So this is about connectivity of a graph. Thank you.